And my name is Gerald Verbeek, and I want to welcome you to this webinar dealing with Foundation Decarbonization and Reuse. I'm the chair of the conference that we've held now twice, and we will have the third edition in March of next year. But in the meantime, what we want to do through these webinars is give some additional information about the whole concept of Foundation Decarbonization and Reuse. Just some housekeeping notes first. As you will see on this slide, during the presentation or the discussion, you will be muted as attendees. That does not mean that you cannot participate. Please use the chat box to submit your questions, and as moderator, I will try to bring those questions in so that we can have a useful and fruitful discussion, and that you also feel that you're participating in the whole thing. Okay, let's go back to the topic for today. I already told you that this thing is organized as part of Foundation Decarbonization and Reuse. During the conference, one of the things that we have done there, slightly different compared to lots of other conferences, is that we have extended Q&A sessions, and the feedback has been very positive about it. It allows a more in-depth discussion with presenters, so that you don't just get a presentation and just a whole bunch of slides, but really a discussion, follow-up questions, and that's what I want to do in this webinar as well. There will be very few slides, and the three people that have been invited, we're going to have a discussion, an open discussion with your input as attendees as well. And the topic that I want to address today is software. The tool that we all use as we do our work, as we are working towards solutions that have a smaller carbon footprint. So we use software, but what is that software doing? Is that software helping us to really come up with a more optimal solution? Is the software helping us to figure out how to integrate the existing foundations at the job site? And is it purely a calculation tool where we just give input and the software figures out, okay, this is the outcome? Or is the software really smart enough that it can guide us to optimize the foundation, to optimize the layout, to optimize the integration of existing foundations? That's what we're going to talk about today. And the people that I've invited are three people that, two of which have already been very active in the conference. If you go back to our website, and I will give at the end of this webinar a link to the website. Two have given presentations, and we're very happy to be joined by a third person, Chris Nelsen, Thomas Zwaenepoel, and Jacco Haasnoot. Chris Nelsen is working with a tunneling company, and I'll let him introduce in a minute. Thomas Zwaenepoel is working for a software company that is providing software, and Jacco is really for a company in between. Yes, they do their own projects as well, but they also have developed software that deals with this topic. So let me just first, let's each introduce themselves briefly. Chris, let's start with you.
Thank you so much, Gerald. So as Gerald mentioned, my name is Chris Nelsen. I'm a geotechnical engineer based in Washington, D.C. in the United States. I've been in the industry, both the deep foundations and now the tunneling industry, for about 7 years now. And I guess related mostly to this conversation, I've been the co-chair of the DFI or EFFC DFI Carbon Calculator Task Force, taking a look at our existing carbon calculator and pushing forward a new development to modernize it. And we'll definitely be talking about that some more. So I'll pass it off to, I guess, Thomas.
Yes.
Hi, good afternoon. I'm Thomas Zwaenepoel. I'm the founder and owner of CloudPiling. We are a Belgian-based software provider for deep foundation contractors. We distinguish ourselves related to other software solutions due to the fact that we originate from people with experience at contracting companies, and as a consequence, we, as an output of our software, determine a data set which is corresponding with what is have to be done on the job site. And I think there the story always starts to, in the end, extract any kind of analyze, which also is the case for the carbon story.
You were muted, Gerald, but I guess it's my turn now to introduce myself. I'm Jacco Haasnoot. I'm from CRUX Engineering, which is a geotechnical consultant, and I'm in the geotechnical consultancy deep excavations now for about 25 plus years. And the last 5 years, my company also went into the field of software development and automation of workflows. And for this, we founded a separate company. It's called SEMS, which is also a CRUX Engineering, but then added with microservices to it. And with this, we indeed develop software to design power foundations. I guess that's sufficient for now. Yeah.
Yeah, thank you. And I'm sorry that was mute. I didn't realize it. The question I had for Thomas, your background, you're also a geotechnical engineer?
Yes, I am. Yeah.
Yeah, so basically, and that's important for discussion. I will ask you some questions about based on your liaison with a certain company, with certain software, but also as geotechnical engineer, because that's what we are really trying to come up with practical experience and practical answers to things that are that apply to foundation decarbonization and reuse. Well, let's start with you, Chris. The first software package that I want to talk about in detail a little bit is the carbon calculator that DFI and EFFC developed more than 10 years ago. Can you tell a little bit about what it does, how it functions, and what the current status is of that software?
Absolutely. So the EFFC DFI carbon calculator is an Excel-based tool. It's free to download from the EFFC website. We can share the link in the meeting notes from this or in the chat. And it functions, if you're familiar at all with the carbon calculation space, as most of these tools do. It's a pretty simple function. You define a perimeter that you're trying to analyze, basically your foundation project. And then you take your activity data, which is anything from gallons of diesel fuel or cubic yards of concrete to cubic feet of steel, and then multiply those by the relevant emission factors. And that gives you a total carbon footprint or emissions from your project. Now, what the EFFC DFI tool did was provide a couple really, really handy shortcuts for foundation engineers and contractors, and really dove into the different geotechnical construction techniques that we use on a day-to-day basis. And it did this in a couple different ways. So looking across any general technique, the tool was able to, or we were able to define primary and secondary emission categories, which was defined as basically a primary emission category is anything that contributed more than 5% of a project's total carbon. Secondary sources were anything less than 5%. And then the tool then requires a user to only input those primary sources, which are going to be mainly the energy usage and the material usage. And those are things that can be pretty easily estimated during a preliminary design process or a bidding phase for a contractor. And then the carbon calculator itself has simplified ratios that then apply some of those secondary emission factors so that the user doesn't have to input every single employee trip to and from the site, don't have to input all the waste factors, all these different things. So it really simplifies the process. And then those simplified ratios and the primary and secondary sources are all specific to the different geotechnical construction techniques that we use. So the tool is very flexible and allows for pretty rapid iteration when you're doing either a design or bidding or comparing different techniques. And And so again, just to wrap this all up, the tool is currently an Excel-based tool. And as I mentioned to earlier, we're going through a redevelopment process right now. We've actually re-engaged with the original developer of the tool, Carbon4, and they're going to be basically reformatting the tool to be in a web-based application. And it'll still be free to access for anybody. And then you'll be able to store your data on that cloud server, and then reference projects and share them amongst different folks within your company. And we'll hopefully then use that to expand the tool and keep building our internal database to provide better solutions for the foundation industry.
Okay. One thing that we'll come back later on in discussion as well, maybe you can clarify it a little bit, is what's being shown here on this slide that will appear on the screen now. This issue about scope 1, 2, and 3. Can you explain a little bit for the people that are not familiar with these terms, what that is really all about, and also the relevance of scope 1, 2, and 3? What is the most important aspect of those three?
Yeah, absolutely. So the scope 1, 2, and 3 breakdown of carbon emissions is one framework for thinking about the total emissions of a company. Scope 1 can be thought of as the on-site and immediate energy use. So that's on-site in the context of a geotechnical construction company. That's the on-site diesel rigs, other diesel equipment used on site, electricity used on site. Scope 2 is indirect, and it's often thought of as energy usage specific to yards and offices. Also, I believe travel is looped into scope 2. And then scope 3, which is generally the biggest one of these three for a geotechnical company, is anything in the supply chain. So kind of before or after the geotechnical project is underway. And you can see in this figure from Keller, materials by and large are the largest component of any project in our scope. And then also included in there is transportation and travel to and from site. So your mobilization and demobilization, and then site waste as well is lumped into scope 3. Relevant to the EFFC DFI carbon calculator, it accounts for scope 1 and scope 3, but it does not explicitly capture scope 2, as that's more of a general company overhead type of emission, and it's not built into the carbon calculator in its current form.
Okay, but as you can see on this thing, it can basically, it's a rounding error. Thomas, going to you now with your software. As Chris mentioned, in the carbon calculator, you define the project, and then it comes up with the carbon footprint of that. Does your project do the same thing? Does it also cover scope 1 and 3, maybe scope 2? What is covered? What has been built in?
Okay. We focus on the complete design part in our software before calculating the kilograms of steel and cubes of concrete needed. That's what's coming out as a result. And in that aspect, I think our software, and for example, a software like the carbon calculator, they are, joint. They can give a complete output of what is the carbon footprint of a project. So I'm happy to hear from Nelsen also that the carbon footprint calculator wants to make the step to an API cloud service. So in the end, within a year, I hope, we can make a general API connection with it, so people can use it as an integrated system. And so everybody has the same basic principle of calculating carbon footprints.
So basically, your software determines quantities, and then something else needs to be done to translate those quantities into a carbon footprint.
Exactly. Because I don't, we as a supplier of software, I don't think we, in the current phase of the industry developing towards carbon calculations, it's possible for us to create an independent way of determining carbon footprints. I think it's better that a general organization like DFI does this kind of development, and that for us as a commercial software company, we can collaborate. So in the end, we can present a transparent result.
Okay. Jacco, how is it in your software? Quantities or carbon footprint?
Yes, indeed. It's also quantities on our side. So the software focus mainly on defining the shapes and sizes and depth of the foundation elements. But I also agree with Thomas that we are always part of a bigger picture of a building or a structure, or whatever. And we have to be in line with what is generally used within those disciplines. So of course, the tool that Christopher describes also with an API functionality to it, it's perfectly fit on our software as well. As I explained, we are actually having a microservice, so it's also something cloud-based that people can use. But we also see that some of our clients, we are, I must admit, a bit more focused on the Dutch situation, that they use our, as it's described, the National Environmental Database, which these numbers are also presented, the CO2 impact of structures, of concrete, of foundation elements, or other structural elements. And we have a couple of clients that indeed use this functionality in their automated workflow to optimize foundations and structures. But if we now also have this international component, it's a great development there.
Now, in a way, though, it is kind of interesting because what the carbon calculator does is what Chris was saying is it takes a project and it comes up with the total carbon footprint. But we all know that materials play the larger part in this whole thing. That's really the overwhelming part. As you can fully, Marcel, if you could show slide 5. What is this one outcome that came out of the carbon calculator? No, 5. What they did was compare a whole bunch of different foundations types, and the brownish part shows you the percentage that is really materials. And you can see that for quite a few of the foundation types, it's more than 80% is material. So that's the overwhelming part. And that then, as Thomas and Jacco are describing, that the focus is on the amount of material, makes perfect sense because that really determines your carbon footprint. But then I have a question for Thomas and Jacco, is that's fine, now you come up with quantities, but if we're talking about decarbonization, we want to reduce those quantities. What does your software do? How does it optimize to come up with smaller amounts of quantities? Or is it basically just a calculator where, just like with the carbon calculator, the user enters the foundation shapes in there, and then it determines the quantities without any further optimization? And Jacco, let's start with you. Does the software provide possibilities to optimize the design, or is it purely a simple calculator of what has been entered?
It does have a nice feature to optimize the design, but for this, you are relying on what's allowable within your national standards. And we have software focused on the Dutch standards, and in that standard, it's a CPT-based design. You see that there's an option if the heterogeneity of the subsurface is low, or otherwise being put as the outcome of your bearing capacity has a narrow statistical bandwidth, then you are allowed to use lower safety factors. And you do this by grouping the CPTs within your total field of CPTs that you have done to to perform your design. And we really optimize this part. And you see, for instance, I guess everywhere in the world now, these big distribution centers are being constructed, which includes quite some design or quite some piles. And especially for these kinds of structures, the optimizing of the grouping of the CPTs is very interesting. And for a client, we have achieved results with which has at least 1 meter less pile depth. And that's immediately also, you could say, a gain for the CO2 reduction, because indeed we saw that the circle of CO2 contribution for the materials is the highest. So when you reduce the amount of material for your pile or for your foundation, you immediately have a gain there.
Right. Yeah, Thomas, in your case, same thing. Is there potential to optimize or let the software optimize the design, or is it purely data entry?
Well, everything starts always from the engineer, and what we want to do is provide an environment where he can, as quick as possible, found out what is the best solution for a case. But of course, yeah, by speeding up the process of designing, you can give the engineer the opportunity to study much more alternatives, compare them, group CPTs, and so on. We also have a lot of focus on integrating all design aspects, which means as there is bearing capacity, negative skin friction, soil structure interaction, but also the detailed design, and do it for each deep foundation technique, which provides a possibility to in a few seconds analyze what is the quantity consequence of a certain design choice. And yeah, we had a lot of case studies. Now we had a case in Canada, for example, last week, and where we could redesign the complete job site with only 12% of the amount of materials they foresaw at the start of the project. So it can go very hard.
Okay. Jacco was already saying the software there is pretty much based on the Dutch design codes and the Dutch standards. In your case, Thomas, you're talking about Canada. Canada obviously has different rules than Belgium, and I know you're also active in the Netherlands. How is the software? How difficult was it, or how different are the design standards in the different countries, and how have you addressed it?
Well, it depends a bit on the culture from our perspective. I think Belgium and the Netherlands are two examples of countries which have a long history of developing their own guidelines and working very code orientated. If I go abroad, I already had a few countries like Canada, for example, where everything they built is also tested in the end. And yeah, we could show them that, for example, using other design codes than they were used to apply, that they were much more accurate in their projection of a reality. And yeah, we start to transform companies even to step away from sometimes guidelines we are less advanced than other ones to help them reduce carbon footprint and also cost, of course.
Okay. Chris, going to you, obviously the carbon calculator doesn't have this optimization in there, but just now going back as your experience as your technical engineer, how do you see that in the area of software? Do you think that software in the end can help engineers to really optimize the design, or do you more see that it's really the engineer's input, the engineer's experience that in the end is going to be determining the effectiveness of all this stuff?
No, I think software plays such a key role here. And there are a couple aspects to it. One is the instantaneous feedback, being able to see the results of minor changes that you might make to your design and small tweaks and how that really impacts. And some things may be surprising, some things may not be. The other aspect is being able to integrate some of these different techniques that we use. If you're integrating piling for a supportive excavation system with or without dewatering, you want to be able to analyze those combinations of different techniques together. And so it sounds like both the CloudPiling and CRUX software can do similar things. And then in the EFFC DFI carbon calculator, you can also kind of mix and match those techniques as sub-projects and integrate them into a whole project. And then you might be able to compare, say, a piling solution that wouldn't need to be dewatered versus maybe a lighter gauge one that would work with dewatering, and then compare those two. So the software aspect really is incredibly valuable for the speed and that amount of feedback. And all that with the caveat, though, that it can also be overwhelming. And I run into this a lot when I'm using different software, is sometimes it's so easy to make a change. You often can either lose track of where you are or you kind of miss your starting spot. So being able to track those changes as you make them and making sure you're just using the software appropriately is just the caveat I'd add on there. Sometimes it can be too easy, and if it's not transparent, then you get that kind of black box issue. So.
Yeah. Okay. By the way, for all the attendees, please feel free to add questions to in the chat box. I'm not ignoring that, but in the meantime, we'll just continue the discussion, and I have then the pleasure of asking the questions that I think are important. But I don't want to just ignore the input from the audience. As I said, I have the pleasure or the luxury that I can ask the questions that are important to me. And as chair of the conference on Foundation Decarbonization and Reuse, and really the focus on reuse, the question then comes in, okay, I've heard all this stuff now, but what if you have already piles or foundations on a job site? How do you integrate it? How does the software then allow you to take account of those existing foundations? Are we seeing possibilities in the software there as well? Or are we then kind of depending on the engineering input? And if this is not within the software packages right now, just as a geotechnical engineer, because all three of you are, look at it that way. And let's start with you, Jacco. How do you see this whole issue of foundation reuse in this light of software analysis, and software tools?
Yeah, indeed. As a geotechnical engineer, I encountered these cases from time to time. Generally, at first, there are always question marks about the quality of the material of the existing foundation. But if that's not an issue anymore, and we also know how long the piles are with a certain certainty, then we are free to design and to integrate these in the new design. And yeah, again, of course, it's maybe, I'm not sure, Thomas mentioned that in some countries it's less regulated than in the Dutch circumstances, but we have to design according to the standards. And the standards are quite clear on what you can do with existing foundations. You even can use the old pile coefficients, which are actually a bit more favorable than the present ones, although there is a limit to the additional load that you can put on the existing piles, and this limit is related to the load that's now already on the piles in the old situation. And fortunately, the calculation rules did not change too much, only the coefficients changed. And so this is fairly easily incorporated in the design software in order to make the calculation itself. But of course, then the interplay starts with the existing foundation and the new foundations, and also how the load is distributed or redistributed to the foundations. And this is an interplay with the structural engineer. And maybe at the moment, the structural engineers are even more aware of the CO2 reduction that they need to achieve in new structures. So we can also learn a bit there, and I think you can come to nice designs together with your counterpart, the structural engineer there.
Okay, Thomas, how do you view all this stuff? Foundation reuse and your software?
Yeah, in our case, yeah, all the projects which are designed within the software, it's by default they are stored in our own database system, and yeah, to contribute to the fact that within maybe 50 years the data is still available and can be reused to not have the same problem as we have today any longer. So that's one of the contributions. And also, as Jacco already said, yeah, in the design you can also take into account the time influence on the quality of materials. But yeah, everything starts with the engineer researching what is already on the job site, and then yeah, using the software to check the existing design, what it could add to the new design. So that's how we look at it.
Going one step further, Jacco was already mentioning it in the Dutch rules. There are very specific requirements where statements made on how to deal with the existing foundations, how to recalculate their capacity. Within the countries where you operate and where you what you've built into your software, do you see big differences there, or is it again the same thing that you said earlier between Holland and Belgium? It's really kind of the same approach there. Can you say a little bit about that?
I think the answer to that question is a little bit nuanced, to say it with a French word. I think in the Netherlands you have a long history, a very long history related to piling. So I can imagine you have a lot of piles below buildings, but in other countries, yeah, like our customers are contractors. How do they earn money? By making piles. So that's maybe one of the reasons none of them already asked me a question. Thomas, can you do something on reusing foundations with your software? Maybe that's already one of the starting points of that discussion. And on the other hand, you also see, like I traveled through the States, Canada, and Christopher will maybe be able to tell more about it, but there I see not a lot of big piling below residential buildings, only below the bigger buildings, mostly only the helical pile systems. So yeah, I think in Belgium, for example, my own home country, reusing foundations, it's not yet on top of the agenda. So yeah, that makes a bit that we as a software provider aren't either already contacted with this question a lot.
Okay. Chris, how do you see that?
If I can add something
sure.
to it.
Yeah.
What you also, of course, see if a structure or a plot already has an existing foundation, pile foundation, and you want, it's usually also in the way of making new foundations. So then an alternative could be to take out the existing foundation and place new foundations there. But by retracting the piles, you also, of course, disturb the subsurface, and you might really disturb it in such a way that the foundation, the new foundation, needs to be much longer than the existing one, or the one if you would place it in within the present situation. So it's also very favorable from that aspect to look into the existing foundation and to reuse it and to integrate this, because otherwise you will actually. Of course, it's also a waste of material and manpower, and you will end up with a new foundation that needs to be much stronger than the existing one.
Yeah.
So maybe a small add.
Sure.
Maybe I have another add. Oh, yeah. Okay.
Let's first go to Chris and then come back to you, Thomas.
I'll probably defer to Thomas and Jacco on this. I work mostly in infrastructure, so I don't see a lot of opportunities for this. There are some. We're exploring them currently. It's often as with most of these things, it's a conversation about risk and capabilities and understanding, and it's something that's gaining more popularity, especially in the Netherlands, especially in other countries. As you mentioned, it's probably not as used up here in North America. So it's a matter of just getting that comfort level and understanding the risks there. Especially for large infrastructure projects, they already have call it enough risks to consider that the owners don't necessarily have the appetite for taking on a new unknown in those situations, which is unfortunate because there's a lot of savings that can be be found there. But I think there are a lot of opportunities on the small to medium-sized residential and commercial projects, but maybe not on the larger risky infrastructure projects.
Okay, before I ask a follow-up question, Thomas, you wanted to add something more after what Jacco's saying.
Yeah, I was wondering because, yeah, the Netherlands are very code orientated in their designs. If you have a job site and you have piles who could be reused, their load settlement behavior, is it differentiating in the code because they are already pre-stressed compared to the new piles, or is that a topic not described in the code? How do you deal with that, for example?
Yeah,
Jacco?
Yeah, I think you just deal with it as you would deal with this as a new foundation. But I understand, of course, you have this reloading behavior. So I would imagine that the structural engineer should have a bit more focus also on the more stiffer behavior of the foundation. So you have to think about this in a more practical sense, and indeed take this effect into account. But yeah, you could say the backbone of the settlement behavior of a pile in the Netherlands are these lines or these graphs that are in the standard. So this is still valid, I would say. Yeah.
Okay. Thank you.
Coming back to something that Thomas is saying and I hear that a lot. Yeah, foundation reuse. Contractors are in the business of installing foundations. So their first thing is, hey, let's not reuse foundations because then my scope goes down, and as a result, the price on the job goes down, and therefore my profit goes down because it's just a margin on the overall contract value. Looking at yourselves as this. Geotechnical engineers, how do you feel about the issue of foundation reuse, and what would you need if you purely look at it from a geotechnical engineering point of view? What would you like to see in the software added that is not currently there to make that the role of the geotechnical engineers more or easier, so that they're more readily suggesting that let's just reuse foundations? Thomas, let's start with you in this round.
From my point of view, a very important aspect is that there should come an end to the practice of people designing things in Excel or file-based things. It should be by law be obligated that everything which is subsoil infrastructure should be designed from a database oriented software with as a result in the end that the complete design is in a database and can be consulted in the future. Where is the structure? How is it set up? And so on and so on. I think that should make a big advance for the future. And every year it's not like that is a waste of time in my point of view, and it could help a lot of engineers in the future. So why not start from it today?
Okay. Jacco, any thoughts on this? What could help geotechnical engineers in this area? What could software do in the future? What it's not doing right now?
Yeah, the developments are going very fast. Well, I'm now in my 50s, so I was already exploring all these things that happen in the cloud and was amazed what's happening there. But last week I also talked about somebody with it, and at the moment I'm amazed about the AI agents that are rushing by and really helping us in optimizing in our workflows and digitizing workflows, etc. So I guess there will be lots of developments there. We're also exploring this, of course, from our point of view. But if you talk about decarbonization, I saw the bar charts you showed at the beginning of our webinar, and you saw that the sheet piles, the steel sheet piles, are the amount of material that contributes. Yeah, so it's 95% of the material is the contributor to the CO2 exhaust of this type of foundation, but the other ones are also quite high. And what we did, I work also with energy sheet piles, and we explored if you use a sheet pile as an energy source, as a sustainable energy source, how much CO2 reduction you can achieve with this. It's you regain the amount of CO2 exhaust for making the steel within 3 to 4 years. So I think what we would be in this topic also a very interesting thing, and I'm also a bit of an advocate for energy piles and energy sheet piles, that we also include the energy function of a foundation. Then of course you're generally talking about new foundations, but you also include the energy piles and its function and its influence on CO2 reduction to in your design. This could be an additional factor for CO2 reduction for buildings and structures as a whole, because
Right.
generally a building needs cooling and needs heating depending on the climate range you are. So that would be, I think, an additional good asset for the foundations.
Chris, any thoughts?
Yeah, I'd just love to echo that. That's a really great point on the energy foundation aspect, and looking at many of those techniques. Almost any board or mined or driven foundation option can be energized, so to speak. Slurry diaphragm walls, board piles, driven steel H piles, sheet piles. This is the first time I've heard about that. That's brilliant. I would love to see that in practice. So yeah, a huge advocate for energizing piles, and it's something that we talked about in the EFFC DFI carbon calculator discussions. Our first phase now is to basically take the existing functionality of the calculator into a web-based format, but we will continue to develop this into the future, and that's definitely one aspect I would love to add personally, is accounting for offsets from energy generation from energy foundations. Would be a really great thing to show in both in any of your softwares and in the carbon calculator.
Okay. Thomas, one thing that when you said that people should not use spreadsheets, immediately that created a whole bunch of questions. People came back immediately. Well, that's fine, but spreadsheets, I understand. Yeah, I know how it works. And all these software packages, it's great, but it takes a long time before I really understand how to use them, and that I feel comfortable with the answers. Question to all of you for the software package that we started out at the beginning. How difficult is it to use your software package? And then how much training is required before an engineer can really start using the package efficiently? Not probably as efficient as you as a frequent user are using it, but still that it makes sense for them to use it. Can you say something about that? Let's start with you, Thomas.
Yeah, it depends. It's also a matter of how we orientate ourselves as a software provider. I think in case of CloudPiling, as I already mentioned, one of the things we try to do to create a system which can optimize foundations, integrate every design aspect in one software, but as a consequence, you also have a large software with a lot of functionality. So that has an influence on learning to work with the software, of course. But I think in case of speed terms, we did. I had a customer and he explained it to me as following, and it was a nice phrase he used. He said, if you go to a race, a car race, you want to have the best car. And if you have the best car, you put in the best racer. But to learn to drive a car, you use a Opel or a Peugeot. And I think it's the same story with geotechnical engineering. If you want to be the best, you need the best tools. And to work with the best tools, it needs exercise.
Okay. Jacco, your software, you said that you use it in-house, but you also sell it to third parties. What kind of feedback do you get from your own staff when they start using it? They probably told you have to use it, so therefore they will use it. And they will still do. But outsiders, does it take a lot of time, a lot of effort to become familiar with the software? What is the feedback?
Yeah, our software is a microservice. So in principle, you send a file with data to us, generally CPT data and what kind of pile you want to calculate, and you get a file back with the answer and also a PDF, which is a nice formatted report. But in the end, it's sending data up and down. And the question is, how do you make sure that this data is what is the front end actually of using this microservice? So in principle, we focused on people that are I would say fluent, but are acquainted with Python, and especially the younger generation is quite acquainted with it. So we see really people that are 5 to 7 years out of school. Python has no secrets for them, but the somewhat older generation, it becomes a bit more difficult, and they really need a nice user interface. So what we now see with our clients that the WizKids within the company, they are really fond of our software and really know how to use it. But the somewhat older generation, or the generation which is a bit more reluctant to change, they really need a user interface. So we are now in the stage that we are also developing the user interface to accommodate those clients as well.
Yeah. Okay. Yeah. Chris, the carbon calculator. How difficult is it for people to start using it? Any thoughts, any information you can share on that?
Yeah, absolutely. It's honestly pretty easy. I think the hardest part about using the carbon calculator is the fact that it isn't a design tool. It's a calculator to take your designs and then get your carbon emissions from that. So I guess the biggest challenge is fitting it into your own personal workflow using whatever design software you're using for your preliminary designs, and then getting your activity data, your material quantities and whatnot, and then putting that into the carbon calculator. But it's really a very limited number of inputs that you need. So once you kind of fit it into your workflow, however you're working with whatever other tools you're using, it's really quite simple. And I think the next step of that is learning your workflow and getting your initial data in, and then how to then use it within your workflow to iterate back and forth. We talk about that instant feedback with software. So if this is just an extra piece that you're doing while you're iterating a design, it's just finding your own workflow with it and making sure you can do that efficiently. So as with any tool, it's just learning how to use it and learning how to fit in with your other tools. But I would say anybody could open it up and figure out how to use it in a day. It's not terribly complicated.
Okay, and probably within a day does not apply to the software Jacco and Thomas you guys are using. Although Jacco, what you're saying is just you send a file and you get an answer back. Probably the format, once you know what the format you just send in, that should not be too complex to figure out what kind of data you need to send. So that could be also done within a day, or is it a little bit more cumbersome to get familiarity with that?
Well, I think in the end, it also it's in line with what Thomas described about driving the car. So you also, of course, need to know what buttons to push and what numbers to fill in order to get a reasonable result, or a result that makes sense. And so that's of course part of working with the software, actually knowing how the standard works. And the other part is how to indeed steer the software, or to give the inputs for the software. And we are a bit more focused on data exchange, so being part of a automated workflow for now. And therefore, yeah, you need also a bit of Python knowledge in order to use our software.
Right. In your case, Thomas, the software is a complete package, goes to the client. They need to do everything. So presumably, even more training required before they know which buttons to push.
Well, yeah, we have a complete, we call it, the software calls CloudPiling, and we have a WikiPiling. So both of them are connected to each other. So you can quickly get access to the explanations, what is meant with the use of a certain button or feature. You have a lot of webinars we give every 3 months. You have instruction videos you can look at. So yeah, and yeah, we have also a support team which you can call, which not every software company these days does any longer. So yeah, mostly I think half a day, and most people are ready to work with it. That's my experience.
Okay. Just something for clarity. I got quite a few questions about that. This webinar was meant, and I'm very grateful for especially Jacco and Thomas to keep it non-commercial. This is not going to be an infomercial on the software that they're providing. We will provide all of you at the end, and also the recorded version of this, the contact information for those companies, and then a link to the website where the software is being provided. But we try to make this non-commercial. The reason why we spend a little bit more time on the carbon calculator is because it's developed by a non-for-profit, readily available. It's open source. So therefore, we were a little bit more open about the carbon calculator. But I really appreciate both Jacco and Thomas to keep this whole discussion, the willingness to talk about it in non-commercial terms. And that's why I can see that some of the questions came in about, well, tell us a little bit more about specifically about these software packages. That's outside the scope of this thing, and I want to keep it that way. But as I said, we will provide links to this software packages and in the chat here later on, and also in the recorded version, and we will respond to all the attendees with that information. To close this webinar, some general points first. Hopefully next year you will come to the conference in Amsterdam, because at that time we will have as a workshop after the conference an event where both Jacco and his firm and Thomas and his firm are going to be participating, where we are going to give a case study to the various companies to say, okay, here you have a situation. It's actually a building where a new structure or location where a new structure has to be built, where an existing foundation is already there, and try to come up with a design that meets the obviously the code requirements, but also incorporate as much as possible the existing foundations. And the various companies will present their solutions, and those solutions will then be reviewed by an independent jury, if you wish, to see what they have implemented and what aspects were maybe ignored or not considered, and what the pros and the cons are. So that's another opportunity where can hear a lot more about these software packages. More in general, as you can see on the screen right now, or it just moved again, but we'll get it back in there. On the Foundation Reuse website, there's all kinds of information there under the resource structure, because one of the things that we are trying to do, and Thomas already mentioned it earlier, Foundation Reuse is maybe not high on the contractor's agenda, but for me and for lots of other people that are dealing with sustainability, Foundation Reuse is something that needs to be reviewed, and that's why we have this open reference source where you can get all kinds of presentations and reports and other information about Foundation Reuse. And you can see there how that, on the next slide, Marcel, if you can see that there, no, the previous one, how that is built up in there, what kind of information is available if you go to that part. Finally, we will also have more webinars. We won't know exactly the date yet of the next webinar. It's probably about 2-3 months from now. But as we go from now in June of this year till March of next year, we will have at least 2, maybe 3 more webinars to present different things, different themes related with foundation reuse. And then we will obviously then also have our next conference, which is in March of next year. And also in between then and now, we will have in September of this year an event in Canada where we have a 1-day workshop associated with the Canadian Geotechnical Society. They have their annual conference. It will be held in Winnipeg, in the central part of Canada, and in September. And we will have a workshop there on foundation reuse, and then see how we can kind of promote this whole aspect of foundation reuse and decarbonization in North America. One example, we haven't talked about it here, but one example where you see foundation reuse an awful lot, and we haven't mentioned it as much in this webinar, is when it comes to road construction. When you have an existing road with an overpass or a bridge, and you need to widen the road or to increase the capacity, quite often the foundations are reused. And when you look at a country like Canada, foundation reuse is predominantly done in road projects and road construction projects, and that is something that we might be focusing on in the future webinar to give a completely different part of foundation reuse, different application of foundation reuse. So that's some general information. With that, we're nearly at the top of the hour. I want to thank Chris and Thomas and Jacco for their contribution, for their willingness, especially Thomas and Jacco, to talk in non-commercial terms about your software. Greatly appreciated. And Chris as well for getting up a little bit earlier because obviously in Western Europe it's the afternoon. Chris is still early in the morning. I hope that this webinar was useful for everybody. Thank you for being here. We will post the recording on the webinar on our website, thefoundationreuse.com, and I look forward to seeing you again in the future. Thank you very much.
Thank you, Gerald. Thomas Jacco, it was a pleasure.
Thank you.
Thank you. It was a good webinar. Thank you all.